Question is, find the inverse of the function g of x is equal to x cubed plus 2 and plot both g and g inverse on the same axis. Alright, so let's just be sure we know what we mean by inverse. So the inverse of g would be the unique function that does this. So when I do g on g inverse, I get x, and when I do g inverse on g, I'll get x. That's the definition of what the inverse is. So informally, it would undo whatever it is that g does. So g does this. So let's see, g, you start with x, and then you cube it. So you do the cube, and then you'd add 2, and that gives you x cubed plus 2. Alright, well g inverse would do the opposite. It would come back here, so it would do minus 2, and then it would come back here and do the cubed root instead of the cube. So g inverse of x would be x, and first we do the minus 2, because we're coming from the other end, and then we do the cube root. So that would be the formula for g inverse. Now that may seem too simple, possibly, for you, so there is an alternative method to get there, and not all functions are as simple as that. So alternatively, well, what we could do is we could think, well, we want g inverse, so until we know what it is, we'll give it a name or a letter. That's one of the classic tricks in mathematics. So let y be equal to g inverse of x. Alright, well, we don't know what y is, so our aim is to figure out a formula for y. But until we do know that whatever g inverse is, if I do g, it will cancel it out. So if I do g on both sides, I'll get g of y is equal to x. But g of y is what I get when I put y into g. So that would be x cubed plus 2. Sorry, y cubed plus 2, because I put the y into the formula instead of the x. So y cubed plus 2 is equal to x. So y cubed would be equal to x minus 2, subtracting 2 from both sides, and y would be equal to the cubed root of x minus 2. And I can do cubed root on any number, that's alright. Square root's a bit tricky, you have to choose whether to do the plus or the minus, but that would be defined by how you defined the domain of g. Okay, so y is really g inverse, so we have therefore g inverse of x is the cubed root of x take 2. So that was an alternative method to get the same answer, and I got the same answer both ways, so I'm feeling good. I've found the formula for g inverse. Of course, you only have to choose one of them in any given situation. So the next part of the question says to draw both of them on the same axes. So let me start a new. Okay, so let's put some axes in. Right, so first let's put in y equals gx, which is x cubed plus 2. I know what x cubed plus 2 looks like. X cubed would be that lovely squiggle that x cubed is, and x cubed plus 2 would be shifted up the y-axis 2 units. So instead of doing its thing at the origin, it would do it just here. So I would have x cubed plus 2 would look something like this. So that's y equals g of x, and that's a 2 there. Okay, well, g inverse, let's think about what we did to find g inverse. Let's go back here. To find g inverse, we went let y equals g inverse of x, yeah, that's good. And then that meant that g of y is x. So the graph is the same as the graph of x equals g of y, because look, x equals g of y. And that's just the same as y equals g of x, but with the x and the y swapped. So when you swap x and y, what you're doing is you're reflecting in the line y equals x. So let's draw in the line y equals x. Whoa, sorry about that. Right, let's draw in the line y equals x. Alright, and then we reflect in that line. So let's see. So, there'd be a spot here that doesn't move. This spot here would reflect over here like this. This spot here, the 2, would reflect over here like this. And then the general curve would just face the other way, so it would kind of be like that. So this would be y equals g inverse of x. And so now I've drawn g and g inverse on the same graph. And so my question is finished.